All right. Hello, everyone. My name is Mihir, and today we'll look at how to make your data pipelines resilient through idempotency. I work at Memorial Sloan Kettering Cancer Center as a bioinformatics software engineer. I lead a small group of engineers and work with many others who build data products for clinical tests developed at MSK. One such example is MSK Impact, which also stands for Integrated Mutation Profiling of Actionable Cancer Targets, which is a tumor sequencing test that detects changes in mutations and genes over various cancer types. Let's look at what are data pipelines. How many of you build or make data pipelines? A lot of us, right? This design pattern was introduced very early on as workflows, which is used to follow a sequence of steps to move data from one source to another. They are quite versatile, and it's due to its nature of adapting to different use cases. We use them in different business use cases, from transferring data from a operational data store to warehouse, streaming data for low latency applications, running large scale genomic analysis, which is what we do, data quality for measuring accuracy, completeness, and the good old backfilling your data points. Why does resiliency matter? We as developers face a lot of challenges when it comes to data pipelines or productionizing your data pipelines. Examples are network failures. For example, in an e-commerce system, network failures can lead to downtime, losing your business on a Black Friday, or duplicate actions, for example, due to a bug or a transient failure, can lead to overcharging your customers for their purchases, leading to customer dissatisfaction. And data inconsistencies, which can lead to data errors and error-prone aggregations, which lead to error-prone decision-making processes. All of these come to one single point, which is while we as developers break our heads on how to fix things in production on a weekend, when these things happen, it impacts business. I work for a hospital where we need to deliver test cases or the test results to patients, and in your case, it will be something else, which is mission critical. Let's see how idempotency can solve this. Idempotency is a property or a feature of an operation which, when rendered, results in the same outputs, irrespective of how many ever times you do it. Now, that is the textbook definition. Let's take an example. I have a 11-month-old daughter. She has this giraffe like toy, and which makes a sound. Every time she presses that button, how many ever times she presses that, it's the same sound all the time. And that is what idempotency means. It means that it will always make the same sound. Let's look at it with a deeper perspective using an example. Here's an example of a data pipeline, a genomics pipeline in a very simplified version of it. It takes in raw sequencing data coming from sequencers. It goes through a pipeline manager, which manages multiple different instances of a pipeline. A sequence alignment service is responsible for restructuring that raw data and creating a sequence alignment map file. And depending on the compute resources you have, it can take about 2 days to a couple of hours, again, depending on the data set size. Run it through a compression service to create a binary version of it to efficiently store it, and then the good old analysis, which runs series of sub-analyses to extract critical data points, and then we store it in a structured format in the database. So this is a data pipeline that can run around 2.5 to 3 days for each and every single instance, and which represents a DNA sequence from a drop of blood or a saliva, for example. What can go wrong? We have all been here. we can experience network failures. A lot of our systems are on-prem, on cloud. It doesn't matter. I think we have, or hybrid clouds for that matter. Network failures can lead to downtimes. It can happen across any of these stages, individual pieces. We humans like to introduce bugs where there might not even be a proper log for it. So let's take an example here. The compression service has some bug. The sequence alignment service completed its job, but the whole pipeline failed. What do? You go back and re-trigger everything. Now you're wasting 2 days of time. That means a lot of resources on your compute clusters, and also you're delaying the results back in the structured database. And there are a lot more issues that can happen in a data pipeline. So when we talk about how do we make our data pipelines resilient, we always talk about failures. And we as developers, we spend a lot of time adding in retry mechanisms, adding a bunch of different things. What my hope is with idempotency is make your pipelines predictable, consistent. And that is, failure-proof pipelines is, in my opinion, a myth. But what you can do is make your data pipelines predictable, failures predictable. And that is what we can achieve with idempotency. Let's look at some techniques or some design decisions that we can take in making your pipelines consistent, predictable across different categories. Let's talk about transactions. Who knew that a parrot from a lot old movie can be used as an example for a transaction, which is what exactly it is. Atomic transactions. It is as simple as that. Use atomic transactions to ensure that you are either in a consistent success or a failed state. Here is an example of transferring $10 from one account to another, and you put it in a transaction and you ensure that you roll back if there are any issues. Transactions go beyond databases. You can have a lot of different mechanics in place. Databases is one example. You can have those in your different processes that work on HPC clusters. Transactions make your pipelines predictable and idempotent. Our databases or our code bases have gotten complicated. We have distributed data pipelines. We do have that as well across different services, different modules, different clusters. How do we ensure that we maintain atomicity while we are running the whole large-scale pipelines? We use distributed transactions. Here is an example where we look at two databases. Let's assume that the two accounts are in two different databases. You ensure that you add transactions in both the places, and you fail if either one of them are failed, and then succeed if both of them are succeeded. Transactions and idempotency go a lot beyond that. You can implement, these are just examples in terms of databases. You can implement 2-phase commits, 3-phase commits. There are a lot of other design patterns that you can implement. But let's make sure that we are ensuring idempotency. And that brings us to the next strategy, which is applying deduplication strategies in your pipelines. Duplicate actions can create a lot of issues. We all know that. It can have different side effects across databases, processes. When you have a lot of retries in place, it can cause a lot of issues. And how do we solve that? Using unique identifiers called as idempotent keys. Here is an example that I'm taking through a client-server approach, where we have a RESTful API for transferring some dollars from one account to another. It is the responsibility of a client to attach an idempotent key and push it to the server. And the responsibility of the server is to take that idempotent key and store it, record the status code request body. Now, what you do next time on the server is depending on your business use case. If there is a retry, you take that same idempotent key, you check it if it is a duplicate, and if the original request was 200, let's say, for example, you can reject it, versus if it was 400, 500, you can let the client retry. And and you can take a step further. You can even if it was 200, you can compare the request body hash to ensure that you can let the client retry. And I think this is really important in payment systems, for example, ensuring that an action is only performed once. Checkpoint and recovery. This is an interesting topic, and I think we implement this a lot. When it comes to a data pipeline, you have different stages or individual components where failures can happen. And state management helps in that. State tracking is a way of tracking each and every event of your data pipeline, critical components where you think that failures can happen, and record it in the database. This way you know that when these operations are performed, where did the instance fail? So you record every single instance and the states of it, and then you use forward recovery, which is another concept which say you can restart from your previous failed state or the ones that was succeeded to then do a quick recovery. It can be a bug. You fix a bug, you push it into production, and then you can use forward recovery to restart the same data pipeline, and you can push it ahead. So this is what forward recovery is about, is ensuring that you are able to move forward and fix your bugs if there are any. If there are any failures, you can retry and from the last succeeded step. Let's look at another strategy. Atomicity or strict atomicity is not always possible in distributed systems, or for example, event sourcing, for example. Compensation strategies are something that are really helpful. This design pattern provides you the ability to say, in this example, if a debit and is succeeded, a credit failed, you can create a compensation event back called refund, and in your use case, it can be something else. And this way, you are able to correct the information in your database, make it back into a consistent state. Compensation strategies are not idempotent by itself. Let's be clear about that. But when implemented in an idempotent fashion with idempotent keys, you have a really reliable approach to compensate your actions where atomicity is not possible. Data transformation and changes. We have a lot of data warehousing, data platforms these days, and schema evolution is inevitable. I've seen existing records getting new data points, new features for it, new data points within the same data set with new features for it. Schema versioning is something that is a crucial topic in idempotency that helps you understand what version of your data set is going to come out through a specific schema, serialization, deserialization. Versioning goes beyond just schema and attaching a version to it. Let's say you have concurrent calls. You have a system which works on concurrent fashion. You're updating your database in a concurrent fashion. How do you ensure that you're able to track changes for a specific attribute? Doesn't matter what type it is, JSON, string. You can use a passive versioning technique where you can take in while making an update call to your server, you can push in a current version of that value and then ask the server, and the server is responsible for checking, hey, did this value change in between my current calls or not? And then apply the update depending on what are the business use cases. If the current value has changed in middle of the calls, you can either reject it or merge the changes. This way, versioning helps ensure that your data sets and your transformations, for example, are idempotent. Things that are coming out of your schema are consistent. Backfills. Backfills is an interesting topic, and I think it goes beyond just normal data pipelines. This is a whole different world for analytics um, and a lot more in terms of machine learning as well. But window functions, please use a range. Select star from limit 100 is not, it's just going to limit your records to 100, but is still going to scan your entire million records. Making backfills consistent is about adding a range. In this example, I'm using a simple date, but in your scenario, it can be a specific range. Let's take an example. You're calculating sales value. If you're doing that and you don't provide a range, your backfills or even any other job is gonna always be unpredictable because the context of the data that you select is not going to be consistent. And hence your results are going to be also, I wouldn't say error prone, but eventually unpredictable because they are changing over time. So as long as you have always work with a fixed window, which is what has helped me over the course of time, and irrespective of if you're doing backfill for original data points or you are calculating analytics metrics. Now that we looked at different techniques of applying idempotency or using or looking at some design patterns, how do we fix our original data pipeline? We use state management and recovery, forward recovery. We implement a state tracking mechanism so that, let's say, the pipeline failed at sequence alignment service, you can again restart and you don't waste the hours and you can move forward. You need to implement idempotent keys to ensure that if there are any retries, you are able to handle them accordingly. This way, it creates a plan for ensuring that your pipelines are idempotent. You create a consistent, reliable output from each and every single step and make it predictable. And I think that is what, in my opinion, the goal is. Now that we have looked at how do you fix it, how do we test it? I like to keep it simple. Identify, test, repeat. Identify the critical components of your data pipelines, individual components, and identify the potential failures in context of idempotency, predictability, consistency, and add unit tests for it. Use pytest. There is a lot of content out there to create tests. So what I'm going to give you is a simple approach that I use, consistent, predictable. Add those unit tests, understand and recognize what are the different failures that can happen across individual components, add integration tests for that, simulate failures. This way you can know what things can fail. And yeah, maybe sometimes you will be able to, you might miss something, but next time you come back, you can fix the test and you can ensure that the predictability matters. Testing won't really help if you have data quality errors in your aggregations in production. That is very difficult to track. So what we can achieve is this: just identify, test, repeat. That brings us to the end of this session. Let me quickly emphasize, please invest in idempotency, which will help you achieve long-term data quality, system stability, and help make your data pipelines consistent and predictable. Thank you. I'm happy to take any questions, if there are any.
So most of this looked like it was about pipelines that do straight up data transformations, data loads, things like that. Are there any techniques that you know of where if you have in a pipeline a remote procedure call, something like that, to be able to make those idempotent as well?
Remote procedure calls. Let me think about that a bit. So when you make those calls, I think network failures can still happen, right? As long as your remote procedure call, you need to make sure that that part of the function is also idempotent. It's a dependency, right? And then how would you achieve that in terms of retrying? So I think you need to trace off steps back. It will work. I don't believe there is any straightforward design pattern. You can implement state tracking, for example, whatever the remote procedure call is. If it fails, the calling component of your pipeline will also fail, which I'm assuming, right? So irrespective of if you're starting a analytics job on another cluster or another server, you're still coming back to the same point of origin, and it will still fail. And then you can retry, and depending on your business use case, you can use idempotent keys or state tracking to again retry, or do a forward recovery. If you're in your case, a atomicity or strict atomicity is not possible, you can use compensation strategies. I've used compensation strategies before in event sourcing applications, and it helps.
Hey, so with the identify, test, repeat cycle, like that's a great way you get rid of all the errors you can identify. But the problem like that I see in my work is you never know when you're done, right? Like it's hard to get the firm guarantee. And short of building up a staging pipeline and like mocking every single network call, every single possible point of failure, and testing those, like how do you? Are there any strategies to like avoid regressions when you're changing these pipelines? Like the CI/CD part of that, it seems
Right.
like you can identify and fix, and then I want to make sure we don't break it in the same way again. Do you have any tips for that?
You don't break it in the same way the next time. So you are asking if there was a bug in the first place.
Yeah.
And
So you
you
like identified,
Right.
you fixed it. Like
So I think I've learned this in my first year of computer science, that this is something that I was taught. You identify a bug, right, and you know where things failed. I just write a failing test, and if you write a fail, and before even writing the code to fix it, so this way you know that it is what you're fixing. You can't really in a CI/CD pipeline, all it is going to do is test what your test scenarios are. It's not going to go beyond that, right? So if you are writing a test case first for your bugs that if you've caught, and then write the code to fix it, you're ensuring that you're able to fix things.
oh no, yeah. Sorry, maybe I wasn't so clear.
Okay.
So like you've identified these issues, you fixed them. How do you know when the pipeline is done? Like, how do you know that your coverage is full? Because you build more pipelines over time.
Right.
You keep building more infrastructure.
Right.
That constantly increases your surface for test coverage. Are there any strategies for like genericizing your CI/CD or your verification there outside of just anticipating every test case? Because that will grow forever.
Right. I don't believe there is a straightforward way to capture that, because at the end of day, what you're talking about is something outside of your test cases, right? If your test cases are always going to be increasing, your infrastructure, you keep iterating pipelines, you keep adding more pipelines. Your coverage is based on the code that you write, correct? And you can write one function to cover the whole code base, to be honest, right? Coverage, there is a difference between having a code coverage versus test coverage. And I don't believe there is a straightforward manner. If there will always be some places that you will miss, or we miss as humans, and then we reiteratively add in those back,
All right, gotcha. Thank you.
of course.
Are there any tools that you use or that you'd recommend to help in achieving idempotency?
We mainly work with open source tools. So for testing, we use pytest. For idempotent operations, I don't believe you really need, there are multiple different things out there. I think there is a workflow engine from Uber, I believe, Cadence. I don't remember. But you don't have to complicate it. You can implement it in a simplistic fashion. Think about the use cases that you have and simplify it. Implementing a simple idempotent keys is something that you can do in simple Python. Any other tools that I use? No, I don't think it is all already written for you. SQL already has transactions. There is a lot of content out there for implementing two-phase or three-phase commits. For example, in a distributed system, so all you have to do is implement those design patterns in Python. We will conclude this talk, and thank you everyone for being here. I'm looking forward to seeing all of you in the next 2 days. Thanks.